Greetings from my recording studio in beautiful downtown Denpasar, Bali, Indonesia. In this second video in the series on expressions, we'll discuss terms in a little more detail. But let's start off this discussion with a review from the first video. We had a table and we had items on the table like chilies and corn and tomatoes. And those items on the table were similar to terms in an expression. On the table, we could move items around. The same thing in a mathematical expression. We can move items around, and that's called the commutative property of addition. Remember, commute means to move. And on the table, toward the end of the video, we grouped similar items like cherries and chilies and tomatoes. And that's similar in expressions to combining like terms, putting things that look the same together. Talking about expressions, every day in language we have expressions, and an expression is a grouping of words in an organized manner that conveys meaning, and words are separated by spaces, unless of course you're typing and you forget to hit the space bar. In math, an expression is a grouping of mathematical symbols such as numbers, letters, and operations, also in an organized manner that conveys a meaning. Now, a mathematical expression can consist of smaller expressions, and whenever those smaller expressions are separated by either an addition or a subtraction, those smaller expressions are called terms. And terms are like words in a sentence. Here are some examples of expressions. At the top of the page we have x add a -3 is simply an expression with two terms, x and -3. 4/9 is a ratio with one term. A little bit more complicated ratio is 3x plus 7 divided by 5a plus b. And this is written as a one-term expression. You might notice that the numerator and the denominator are both two-term expressions in their own right. So that's an expression, 3x plus 7, and the denominator 5a plus b. And even though that these are expressions as written, this is a one-term expression. Finally, at the bottom of the page, x plus 4 in parentheses times 3x minus b is a single term consisting of two-term binomials. Something written like this, 3x minus b is a binomial. It has two parts, has the x term and the b term. Binomial stands for two parts, two names. Finally, we have this expression, 3 add this fraction, subtract this product. So this is an expression with three terms, a number, a fraction, and a product. Note that terms can be made up of expressions themselves, like this fraction. The numerator is an expression, the denominator is an expression, yet that's still just one term. So now that we've learned how to identify terms, let's turn our learning to similar or like terms. Recall whenever we had the table and somebody had come in and messed it up, we had different groupings. We had corn over here on the left, corn over here on the right, chilies here, tomatoes, tomatoes. In this visual, that represents a term. That represents a term. The 2 tomatoes, the 2 chilies, 2 more tomatoes, and finally this corn, all represent items on the table, and that's very similar to what we see in expressions. So let's get a formal definition of similar terms before we move any further. Terms are similar when they have the same variables raised to the same power. Let me give you some examples. I'm just going to put a bunch here on the table, on the screen. So we're looking for terms that have the same variable raised to the same power. When we're talking about power, we're looking at this. That's an exponent, that's a power. All of these others, like 3x, it has a power, but it's 1. Y has a 1. It's just understood. It's called a hidden 1. Both of these have 1s. This has a 1. Maybe it's a little bit easier to see now. So we want to identify, we'll start with 3x, and we're going to move around the screen until we find another x term with the same power. That's not it. 6x squared, even though it has x, it has the same variable, but it doesn't have the same power. But here's 1, 2x to the first. So I'm just going to kind of put those together. I'm going to mark him out so we don't have to deal with him anymore. Now I'm just going to go to the 5y to the first power. Go ahead and underline him. X squared differs in 2 different ways. It's an x term and it has a power of 2. Moving on, here we have x to the first, y to the first. That's not exactly the same as y to the first, but we come to this one, right? This term and this term is similar. Now we'll do the x squared terms. I'm going to go ahead and mark these guys out. We don't have to deal with them anymore. 6x squared, we're looking for another term that has an x squared term in it. So we'll underline him to remind ourselves what we're looking for. Don't have to worry about this guy. This guy, xy term, is not the same, but there's 1 here, right? So this and the 4x squared terms are similar terms. Just about to run out of things. Now we have 3x to the first, y to the first power, and we're looking around at what's left. There's nothing left. This guy is all by himself, and we have an x squared y term, and he's all by himself. So we've identified all of the similar terms. Now, the nice thing about similar terms in an expression is that we can use them, we can combine similar terms to simplify an expression. So here's an example. We have 6x subtract 3, add 5y, add 2x, add 8, add 6y. The way I typically like to do this is I start off at the left-hand side and just work my way across the expression. So I have a 6x term. I'm going to just move to the right until I find another x term, and I find it here, and I'm just going to write them here like this. I'm going to work down the page vertically, and I go ahead and mark that one out so I don't have to deal with them anymore. Now I have a number term, this -3. I'm just going to move across the page until I find another number term, and I see add 8, and I'm just going to write that here, and I'll mark him out so I don't have to be concerned with him anymore. The final thing that I have left is 5y. I'm going to leave him right where he is and work across the page until I find the next y term. That's right here. And I'm just going to move him there. And then once we've done that, this is going to look a lot like an addition that you did in grade school. So 6x add 2x would be 8x. 8 subtract 3. That's a positive 5. And then 5y plus 6y gives me 11y. And so we've simplified this. Mathematicians might go a little bit further with this and rewrite it as 8x plus 11y plus 5, keeping the constant term off to the right all by itself and leading with the variable terms x and y. Now here's one for you to do. Go ahead and pause the video for a little while you work this out. And when you come back, we'll do the solution. Okay, welcome back. Once again, we're going to start at the left-hand side of the expression and work our way to the right. So this one starts off with a number term. So we can skip this x term, we can skip this y term until we get to the next number term. There it is, add 3. I'll just move him here, mark him out to remind myself that I've actually used that term. Now we get to the x term, still moving from the left to the right. So this is an x term. I'm going to scan across the expression till I find another x term. Right there it is, 8x. That's an add 8x. Go ahead and mark him out. Still moving to the right. We have a y term, 5y, subtract 2y. Would look like this. And then we're just going to add these things down the page. 4 add 3 is 7. 8 subtract 3 is going to be 5x. And then 5y subtract 2y would be a positive 3y. And even though that's sufficient, like I say, mathematicians prefer to keep things a little bit organized differently. So I'm going to put 5x plus 3y, add 7. We'll put the x terms before the y terms. I mean, that's just something that we do. And finally, the constant term out at the end. So in summary, similar terms have the same variable raised to the same power. That would be something like this, 6x plus 2x. It has the same variable, x in both cases. It has the same power even though it's not listed. Notice that if we had 6x plus 2x squared, the variable is the same, but the power is not the same, so these are not similar terms. And finally, we can combine similar terms to decrease the number of terms in an expression to make an expression more manageable. And in the long term, whenever we get to equations, it will make equations much, much simpler to solve. So here we are at the end of the day, and you know there's only one thing left to say, and that is that's all, folks. Thanks for watching, thanks for listening, and thanks for learning.